All right, folks. So I'm going to talk today about pointers in C and arrays, okay? Because they're highly related and they're very, very confusing to most people when they're starting C. So first, let's talk about types real quick. Let's talk about, like, for example, what a char star, an int star, a struct, what they really are, right? So this program, all it does is it just prints out the number of bytes that compose each of these types. So what do I mean when I mean number of bytes, right? So a program ultimately is just a bunch of bytes. And ultimately it looks like, as you probably know, a bunch of binary like this. It's just like a whole bunch of ones and zeros. So each of these ones and zeros, or each of these groupings of four, will be directly related to one hexadecimal digit. So for example, the number 10 is A. So you go 0, 1, so you go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And instead of going to 10, you go A, B, C, D, E, F. Okay. So if you count all that up, it ends up being basically 0 through 15, which gives you 16 different possibilities. And so the way the number system works is every single one of these um, digits basically can map directly to a grouping of four binary digits. So for example, 0 would be 0000, 1 would be 0001, and then 2 would be 0010. And the reason why is because when we're looking at just this group of four right here, 0 is in the place of the ones. We got 1 in the twos place. We got 0 in the fourth place, and we got 0 in the eighth place. So the point here is that all files on a computer are going to look like a whole bunch of bytes, binary groupings, basically. And so, for example, 1A, 2B, 5, 6, 7, 8, 9, 1C, C1. So this is how binary ends up being translated to make it in a more compact form for humans to read and for us to reason about and use. So if you've heard about assembly language, for example, assembly language is just a group of bytes like this. And for example, 1A may mean add the following two numbers. And then how do we know where those numbers are? Well, maybe they're at this memory address that is composed of all these digits right here, and etc. So we're basically just reasoning about these bytes. And so it's important to note, let me actually open up an hex editor real quick. And I'm going to show you this. So this is actually a program called Fresh Paint, which it seems to come with the Windows Store. I don't know, it was already on my computer when I got it, but this is actually the binary file. So I took the .exe file and I opened it up in a hex editor, and as you can see here, it's exactly what I said. It's literally just a big, huge, long listing of bytes. That's all it is. And what happens is the processor, it makes sense of these bytes based upon something called offsets. So it first checks the first two, and it says, okay, we're expecting a 4D and a 5A here if this is actually a proper DOS or Windows binary file called portable executable. And then it says, okay, now let's examine the next 59 or so bytes, and let's see what's there. And then in this spot right here is the address to where the header information is for the portable executable file. So it is 00000040. So if we were to go down to 00000040, we would find the PE header, which is right over here. So you can see 00 is abbreviated, but this is 00000040. And right here is our PE signature, and then this starts a whole bunch of PE or executable file header information. So the point here is all files are this, even if it's not an executable file. For example, I'm going to open up a different file that's not an executable file, right? Let me go to my documents. I'll just find like some random file to open up. I don't even know what this is. This is a PDF file though, right? No, let's open up a doc file. That'll be interesting. This is actually my resume. So let's check this out. What is it? It's just a bunch of bytes still. You know, it's the formatting is different, but it's a bunch of bytes. And so we're going to get past that. And the point of explaining all of this is that when you're looking at an array in C, so let's make an array, right? I'm just going to declare one out here just because, right? So I'm going to say char color 50, right? So what is this right here? This is a group of 50 chars which make up this array. So in other words, the computer is going to take and it's going to allocate 50 times the size of whatever char is in memory in the stack in this case, because I didn't put it on the heap, I put it on the stack, and it's going to set that aside for our usage. And in this particular case, each char is 1 byte, so we got a 50 byte array here, right? Now, the question becomes, how does the computer actually refer to this array? In other words, how does it get there? Well, if you needed to find a long grouping of numbers starting at one particular number, what would you do? You would look for the first number, right? So the way the computer locates this array is the first element, the address of the first element. Okay, the memory address of the first element of the array is how the computer locates this array. Now, let's say we wanted to store that memory address so that we could reference the array, right? Well, what we could do is we could say char star, which stands for character pointer, and we'll say array p equals address of the first element of the array. Now this would be the same thing as saying char star array, I don't know, p2 equals color. And my bad, I meant to say color there. Got a little carried away with the array thing. So we take the address of the first element. So we have 50 elements in color. We take the address of the first element and we place it in this variable called array p. Now, any variable that holds a memory address is called a pointer. Once again, a pointer is just any variable that holds a memory address, and each memory address on a particular architecture is always the same size. So for example, on x86, every single pointer is 4 bytes, which is 8 digits. And on 64-bit x64, they're 8 bytes each. It doesn't matter what type of data they're pointing to because that's not the point. The pointer holds just a memory address, but it needs to know what type is inside that address, so that way it knows how to use the information, basically. So that's why you have to do charstar, or for example, int star, or I don't know, double star, or whatever. You have to do that because when the CPU goes to actually use the data, it needs to know how to use it, and it needs to treat it properly. So charstar array, oh man, not my day, huh? All right, so charstar array 2 equals color is, so color in this context here, when you're not giving a specific element, is synonymous with the first element. So it's the address of the first element of the array. Now, this is a very important concept because another thing that happens in programming is we call functions, right? So let's say we have a function called myFunction, and it takes an integer, and we give it 50. Well, what's really happening here in my function is we're calling an address. And that address is the beginning of the instruction list for the function. So a function is like a recipe. It's a long list of instructions, and just like we see in assembly language. And when you actually call a function, all it's doing is it's taking the CPU and it's moving it to the first instruction of that function, and then the rest of the instructions just come sequentially after that. So that's an important concept to know as well. So there's this whole notion in computer science of the address of the first of something, the address of the first element of the array, the address of the beginning of the struct, the address of the first instruction of the function. And it's very, very important because this is how the CPU actually works. At the end of the day, it doesn't see, this P2 or printf and struct. All it sees is a series of instructions and a series of commands that tell it to jump to other addresses with more instructions and or other information. And so that's really what's going on behind the scenes. So if you understand all that, it's much easier to then understand pointers. And I think that's one of the big problems why people are confused about pointers, is because they don't understand really what's going on behind the scenes. So I'm going to get rid of this function now, and I'm going to then cover a few other things here. So what's the difference between charstar my string equals go away versus char my string to array equals go away? So what's the difference between this, right? So charstar is a pointer to a string in read-only memory. So you can't change this. So you can have my string and you can use it. Like you could do something after the fact, like this. You could say printf my string colon %s, and then you could say like my string, and this is a valid thing to do. What you can't do is you can't say my string 2 equals t, thinking that you're going to change this space into a t. That's not going to happen, because the problem is that rather than using an array per se, you're actually using a pointer to a memory address, which is in read-only memory, and then this string is stored there. And by the way, inside of this string, what you can't see is actually a null terminator, which C gives you automatically. And same here too, there's actually a null terminator here. C gives you that automatically as well, that when you declare it like this, right? But these two are very different, because this is not changeable or immutable. This is mutable. This is change. You can change this. So for example, you can't do that, but what we can do is we could say my string 2 3 equals the character A, and we will change the fourth element here. So we go 0, 1, 2, 3, 4. So that W will become an A. That's valid to do that. Okay, because this is an actual array, or sometimes it's called a buffer, or we could say a buffer array or an array buffer, whatever. You could kind of argue that this is also an array, but since it's in read-only memory, it doesn't really matter because you can't change it anyway. But this is really a true array where you can actually modify each element using this bracket notation. And now this holds true if you pass these things into functions. So for example, let's say we have a function, let's say we have a function like this. It's void change char, and then it takes char star, let's just say string, right? And then it starts, and then it ends, right? And then we do stuff in here. So what we could do now that this is defined, is we could say change char, and we could pass in my string 2, and this would be valid, because what we're doing is we're passing the address of the first element of my string 2 in as an array, and this is okay because we're passing an array in, and then we could go ahead and change this. So we could say str2 equals C. And what it's going to do is it's actually going to change my string 2. So it's going to be 0, 1, so 2. So this space right here is going to become a C. And the reason why is because we passed the address of my string 2, which is out here, outside the function. We passed that address into the function. And then we're acting upon that address here. So even though we're not returning, like we don't have to return anything, we could just return nothing here. It's still going to actually change the original array up here. Now, if we were to pass in my string, though, for example, not my string 2, but my string, which is in read-only memory, this would not work. This would cause a segmentation fault because we're trying to change read-only memory, which you can't do. So it's very, very important to understand this concept. Now, another confusing part about C can be this whole thing right here. So what's the difference between this and this? Well, there's not much depending on what you pass into this function as an argument. For example, you could have this notation and you could still pass read-only memory pointer in here. You could still pass a charstar in here. Or you could have this notation and you could pass an array in here. It really depends on what you're passing. But for all intents and purposes, it's important to note that when you're dealing with an array, you could either pass in the name of the array, like my string 2, or you could pass in the address of my string 2, first element. These two things would be exactly the same. They're just both going to be a memory address. So they're going to be something like 806787A2 or something like that. And you'll often see these memory addresses displayed as 0x, which is the abbreviation for hex in C and many other programming languages. So it might just be an address like this. And this address right here ends up actually being copied and then pasted basically in here like this. You know, it goes in as a parameter. And then that address gets acted upon. So str gets replaced basically. So it would become 806.78.782. And then move in 2, which actually is 3 because it starts at 0. So move in 3 spaces and then set that third space to C. Now here's the key thing though. 2 what? What is 2? So we're moving in by 2 chars. And in this particular case, each char is 1 byte. But let's say we're dealing with integers, right? So let's say we have, let's say we do this. Let's say we have int array 50, right? So every single element, so let's say, what is int array 2? How big is that, right? Well, on this architecture and this configuration, an integer is 4 bytes, I believe. So in this case, every single time you move to the next one, it's going to move up 4 bytes automatically. So 3 is going to be 4 bytes after 2. 4 is going to be 4 bytes after 3. 5. So the point here is that we're not, just because it is one array element number doesn't mean we're talking about 1 byte. It's actually the number of bytes that are associated with the type of the array. And in this case, the array type is an int, so it moves up 4 bytes every single time. Now, we can do this exact same thing with something that they call pointer arithmetic, right? So this is what's really cool. So now we're going to make an int pointer, and we're going to call it int array p, and we're going to say is the address of, just for the hell of it, we're going to say int array 0. So we're going to be real explicit here. You don't have to do this. You could just say equals int array without having the address and the 0. But the point here is that we're taking the address of the first element of int array and we are placing it inside of int array p, which is a pointer. right? Now, what's cool is instead of doing int array, like, for example, 1, we could just do int array p, and then let's say we want to move to the next. Let's say we want to go to 1. So right now, int array p is at 0 because as we've assigned it 0 right here. So let's say we want to go to 1. So we could just do int array p plus plus. And what that's doing is it's saying, okay, let's move 4 bytes in until you get to the next element. And now int array p is the address of int array 1. And now let's say we do it again. Let's say we do int array p plus plus again. Now int array is the address, or int array p holds the address of int array 2. So in this manner, we're basically doing the same thing as saying int array 1 or int array 2. We don't even have to do that. We could just use what they call pointer arithmetic, because we're adding 1 to this pointer, and when you add 1 to a pointer, it adds 1 times the number of bytes of the pointer type. So since we're using an int pointer, it adds 1 times 4 here in this case. And so therefore it adds 4. So we're moving up 4 bytes into this array, which means we're moving to the next array element because each element is 4 bytes in size. So it's very important to understand that. Now, I'm going to get rid of some of this, and I'm going to talk about a few other cases here. So what on earth happens if you go like this, like plus plus int array p, right? This basically is going to do the same thing. It's going to increment before the operation, but we're still moving down the array into the next element of the array. However, if you do something like this, if you do star int array p, now what you're doing is you're dereferencing the array element. So whichever position in the array that int array p is at, so let's say it's maybe at element 3 of 50, then you're saying go into that element and pull out the value stored there and then give me that value. So this is totally different. So if you do something like int array p equals 55, you're setting whichever array element that we're currently on to the value 55. You're not messing with our movement through the array. And for example, you might see something even more crazy like int array p plus plus equals 55. And what's going to happen is that when this expression here gets evaluated, first we're going to assign 55 to int array p, to the position that int array p is pointing to in the array. So say we're pointing at, let's say we have the address of element 7. Well, it's going to assign the value 55 to it, and then after it does that, is then going to move to element 8. So then what you can do is you could use loops like, let's just say for int I equals 0, I is less than 10, I plus plus. And see, usually you might do something like this, where you say int array I equals 5 or something. Let's say you want to just set the first 10 elements of int array to 5. You could do that, right? Or what you could also do is you could say int array p, or star int array p plus plus equals 5. It's the same thing, because what's going on is every single time, so we're starting at position 0, int array p starts at the position 0 in the array, and then it sets it to 5, and then it increments. So it moves to the next element. So then when we go around the loop, we're now going to be at element 1, then element 2, then element 3, then element 4. So it's the exact same thing as if you were to say int array I equals 5. So you don't even have to actually use this bracket notation if you don't want, basically. You can just use these pointer arithmetic. And you know, this is just the real basics of pointer arithmetic. You can do a lot crazier things with pointer arithmetic. You could say like int array p plus 5 to add, 5. You can move 5 spaces in. You could say like times 4. There's all kinds of stuff you could do if you really wanted to. You don't have to stick with plus plus. So if you wanted to, skip a few elements, and especially with bigger arrays and things like that. So just to recap, this function here, let's say, takes a charstar. It's very similar to taking a array. You could pass addresses to read-only memory here. You could also pass addresses to regular array buffers in here. And if you do pass an address to read-only memory, which would be a charstar address, just like charstar my string here, you're not going to be able to change anything in the element, or you're going to have, or any element in the array, or you're going to have a segfault. If you do pass an address of a regular array, then you're going to be able to go ahead and change it, and the function can change it without returning anything. And that's what's neat about C. You can't always do that in other languages. You can do that in C. It's pretty cool. Other languages have other options to do that, but they mask the fact that this is what's really going on underneath too. And then you can directly change arrays like this. You can't change at all pointers to read-only memory. And then you can now what you can do with read-only memory is you can actually read it like this. So you could do something like this. You could say the second char in my string is, and you could say my string 1. This is valid because we're not changing the memory pointed to in read-only memory by the character's pointer in my string. We're just reading, and when you're reading, you can actually use bracket notation, but you can't assign. You can't do equals b. So I just wanted to bring that up too. So this may seem really confusing, but after a while, if you keep practicing, you'll get used to this, and I highly recommend you just keep practicing, because that's the most important thing. Just do this. Just make these stupid little programs, and don't do exactly this, because this was kind of like a little demo. You wouldn't want to have all these variables and functions outside of the main function, but just practice with all these different things and just play with them. See what happens. See what happens when you increment a pointer to a character, or you increment a pointer to an integer. Look at the size of pointers. Look at the size of arrays, and just practice and practice and play with all these things. You don't have to write super useful programs, and then you'll become comfortable with the syntax, because the syntax can be confusing, because sometimes the star means like this. What we're doing here is we're actually declaring this thing as a character pointer, and then other times the star actually means go to that pointer and get out data, which is called a dereference. So, and that's what's happening right here. We're basically saying go to this pointer and now take the value at the pointer and replace it with the value 55. That's called dereferencing the pointer. And so they're kind of confusing because there's a lot of star usage and a lot of ampersand usage, but you'll get the point eventually. Just remember, whenever you put an ampersand in front of something, a variable like this, it's going to get the address of it. And I think that's all I had. That's definitely enough content, but this is what gets people like crazy with C programming. And it's the syntax, and then it's also the concept of having memory and having things pointing to it. For example, like this loop here, let's say this array ended and we keep iterating through the loop for some reason. Like, let's say we have like 500 here on accident or something, right? Well, now this is going to cause a problem because this array is not that big. It's only, I think we created it as 50 spaces. Yeah. So there's only 50 elements here, and now we're trying to go 500 elements in, and we're gonna have a crash basically, or bad things will happen. It's called undefined behavior in C. C lets you do that, and it doesn't always catch it when you compile it. Sometimes it won't tell you anything, and it'll just let it happen, and then your program will just behave weird. And that doesn't happen so much in like C# and Java, and JavaScript and Python. So that's one of the things that trips people up. And it seems really simple. Like you're probably thinking, oh, I can go do this, I can bang this out, no big deal. And then when you start writing the programs, all of a sudden you're going to have these weird crashes and segmentation faults happening. And that's where C really kills you. It's not in the learning. The learning's easy. K and RC, it's written by Brian Carnigan and Dennis Ritchie, is only like a 200 and something page book, 200 or 300 pages. This is a very small book for computer science and programming standards go. But like trying to actually implement all the knowledge is what will get you. So you end up having to use GDB to debug and things like that. We'll cover that in another video. Anyway, thanks for watching, and I hope this helps you understand pointers and arrays in C.